Hello coders. In today's problem solving session, we'll take a deep dive into the combination sum 2 problem. We'll uncover techniques, build our solution step by step, and focus on intuition rather than rote learning. So let's get started. We are given a collection of candidates, which is an array of integers, and a target number. We need to find all the unique combinations in the candidates where the candidates add up to the target. Let's take an example to understand this better. Our given input is this 10, 1, 2, 7, 6, 1, and 5, and our target is 8. So to do this, we can take 1, 1, and 6. So this could be one of our combination, which adds up to the target 8. Another we can take is 2 and 6. So we can take 2, 6, which adds up to 8. Another combination that we can take is 1, 2, and 5. 1, 2, and 5, which again adds up to 8. And the other combination we can take is 1 and 7, which again adds up to 8. So these are my combinations that add up to the value 8. Let us take another example of 1, 2, 2, 2, and 5. And let's see if the target given to us is 5, what are the combinations that we can take? We can just take 5 as it is. So 5 becomes our combination, one of the combinations. We can also take 1, 2, and 2. So we can get 1, 2, and 2, which again adds up to 5. Now notice we have certain elements that are duplicates. So we have taken this 1, this 2, and this 2 to form our candidate. We cannot take this one and then this 2 and this 2 and say that that's also a candidate, because that becomes a duplicate combination that we already have. So of these 3 2's, we could only pick either any of the 2's, either this and this, or this and this, or this and this, to form our combinations sum. So let's see how could we solve this particular problem. So if you are given this array 2, 5, 2, 1, 2, and the answers that we are supposed to find, the output, have to be in the increasing order of the numbers themselves. So you can see here we have 1, 2, 2, and 5. So we need to have them in the increasing order. So to do that, let's first sort our numbers. That's the first intuition that we get. Let's sort our array to 1, 2, 2, 2, and 5. So once we have sorted, if we find all the combinations and check if each combination adds up to the target, we may get our answer. So for example, we may take this 1, and then we may take the 2 here, we may take the 2 here, and we may take the 2 here, we may take the 5. So this is one combination that I have. Another one I can do, just take 1 and take this 1, 2, and take this 1, 2. Or I could do 1, 2, and 5, which is this 5. Another combination that I can find, maybe if I take start from the 2, then I can take the next 2, and then the next 2. Another combination could be 2, 2, 2, 5. Another combination could be just 2 and 5. So you can see there are many combinations that we can get. But can we go in a order to find all the combinations that would yield us the correct result? So let's try to understand how we can break down this problem and generate all the combinations for a given array. Let's say we are given the candidates as 1, 2, and 3, and the target that we have to find is 3. So imagine we start with an empty array and we build this empty array into all the different combinations that we can get. So as we are iterating over the given candidates, let's say we are at I equals to 0, which is this one. Now either we can include this one in our combinations or we can exclude it. So let's say if we exclude it, then our array still remains the same. But if we include this particular element, our candidates or our array becomes 1. Now next, let's say we move to our I equals to 1, which is the element 2. Again, we can do the same. Either we include that element or we don't include the element in our combinations array. So let's say we don't include that in our combinations array or we either include it. So if we don't include, we still end up with the same empty array. But if we do include from this particular position, we end up with an array consisting of just 2. Now same, from this particular point, if we exclude that array or exclude that number, we end up with 1. But if we include it, then we add 2 to this particular one and we get an array 1, 2. This is our combination. Now, at each step, we could check if our array of combinations is adding up to the target, and if it does, then we get one of our candidate solutions. Now, similarly, if we continue and we go for I equals to 3, we can see from this empty array, if we don't include it or we exclude it, we get an empty array. If we do include, then we get 3. Similarly, from 2, we just get 2 if we exclude it. If we include the 3, then we get 2 and 3. And similarly, from 1, this, and from 1, we get this. We can do the same here as well, where if we do include it, we would get 1, 2, 3. Now, in this way, when we start from an empty combinations array and we go over either including the next element or excluding the element as we go across all the candidates, we could find all the different combinations that could be present in the given array. So let us take another example and try to find what kind of a technique or programming should we do to find all the different combinations for a given array, and at what stage can we find the results or the answers that add up to this target, and how do we arrive at our final solution. So suppose we are given the array 1, 2, 3, 4, and 5. As per our previous understanding, we start from the first element or the 0th element here, and we can either include it or exclude it. Let's say we include this particular element. Now, we can say that from this 1, when we include 1, we can either go to 2, or we could go to 3, or we can go to 4, or we can go to 5. So we can go to different elements from here, and if we go to 2, let's say, then we do the same and we can go over all of these different elements, and we can do the same as going from 3 till the end or from 4 till the end as we go over each element. So to understand this better, let's say I start from 1, which is I equals 0. Now all of these values here should go from 0 till 0, 1, 2, 3, 4 till I equals to 4, right? So what happens here then? We could either get 2, we could either start from 3, we could either start from 4, or we could start from 5. So these are our possible values that we can start building our combinations array with, right? Next, when we go from 1, we could either go 2, right? Or we could go to 3, or we could go to 4, or we can go to 5, just like how we saw. So similarly, how we went from 0 to 4, we actually have to traverse here from index position 1 to 4, so that we get each value. Now similarly, from 2, we could either go to 3, 4, or 5. So I can go to either 2 or 3, sorry, yeah, the index values, or this. So this goes from index position 2 till 4. So let's see what happens when I just take 1. I just get this combination 1. Now when I go to 2 here, I could get 1 comma 2 as one of my combinations. Then when we reach here, I could either get 1, 2, 3, or 1, 2, 4, or 1, 2, 5. Similarly, I could also get 1, 3, 4, 1, 3, 5. Or I could do 1, 4, and 5. Or we can do 1 and just 5. Right? Now, continuing this, we can see we either go from 3, 4, and 5, or we then go from 3, we can go to 4, or we can go to 5. So this loop runs from 3 to 4. And finally, we have our last element, which is just 5. So this is just 4, index position number 4. So you can see here, we first go from 0 to 4, and then we go from 1 to 4, 2 to 4, 3 to 4, and just the final 4. And for each of these values, we iterate inside. So this goes from 0 to 4. So the next one goes from 1 to 4. Now, if we are here where we are at I equals to 1, then we go from 1 till 4, and the next one will go from 2 to 4. So because this is a 2 value, so it can either be 2, 3, 2, 4, or 2, 5, right? Similarly, here it can be 3, 4, or 3, 5, and 4 can be just 4, 5, and there's nothing, and then we just have 5. So you can see the different paths that we can create here. So my path could be 1 to 2, 3, 4, 5, and this becomes one of my combinations. Or I can do 1 to 2, 4, and 5. So this could be one of my combinations, 1, 2, 4, and 5. Or I can do 1, 2, 3, and 5. We could also do 1, 2, and 5. We could do 1, 3, 4, and 5. 1, 3, and 5. Or we can do 1, 4, 5, or just 1 and 5. So we can do all of these combinations 1, 2, 1, 3, 1, 4, 1, 5, 1, 2, 3, 4, 5. And similarly, once we are done with 1, we can start from 2, and we can keep our iterations going. So we can do 2, 3, 2, 4, 2, 5. We will not go above, but we'll go to the next one only. So we go from 1 to 2, 1 to 3, 1 to 4, 1 to 5. And at each iteration, we go over each of those values again, right? Now, similarly, for 2, we can do 2 to 3, 2 to 4, 2 to 5, and at each step, we again iterate within that. So we can see when we fix 1 here, and we want to find all our paths, we can do 1 to 2, and 1 to 2 can create these many paths more, and 1 to 3 creates these many paths again. This one, and 1 to 4 creates 1, 2, 4, 5. 1 to 5 is just done, and then this creates this path. And 1 to 3 can create 1, 3, 4, 1, 3, 5. 1 to 4 can create 1 to 4, and just 1 and 5. So as we are creating each of these different paths, we can check if a given target is less than or equal to the sum of the current path we have, then we find our answer. We'll look at that a little later. But for now, we can see that to construct every path, we have to iterate from I equals to 0 till n. And for each I equals to 0, we need to again iterate from I equals to the previous I plus 1 till n. Now, this is important to understand. At each, so from each I equals 0, can you see that we are actually making a recursive call which iterates from I plus 1 till n. And from each of these, we again make a recursive call to go from the previous I plus 1 to again another I plus 1. So it becomes actually I plus 2 till n. Now, how does this look like if we write a recursive code? So we know we have to run an iteration from an index value till the end, that is n, and we can construct a path saying path equals to path plus the array of the index value, and this can be called recursively. So let's say we do recursive of, we go from index plus 1, so we go to the next index and we send the path that we are currently at, and the whole of this will go into a recursive function which takes an index value and it takes the path that we are generating. So let's take an example and try to see how this works. So first we can send the index value to be 0 and our path is an empty array. Now when this happens and it goes into the recursive call, I goes from 0 till n, that is 4, and my path now becomes just the first element. And we go into a recursive call inside this where now index goes from I plus 1, so that is 1 to 4, and here my path now becomes 1 comma 2, and this again goes into a recursive mode and my index here becomes 2 to 4, and the path then becomes 1, 2, and 3, and so on. Let's take an example which contains duplicate elements 1, 2, 3, 3, and 5. And how does our code evolve now? To save our answers of the combinations that we get and to also avoid any duplicate results. So in this example, we go from I 0 to 4, and when we are at 0, our array is just 1. Now from 1, we go into a recursive call and we either take 2 or this next number 3 or the next one 3 or this value 3. So let's say if we take 3, we then go into a recursive mode and we take either 3 or we take 5. When we come to this 3, we can again go to 5. So you see from this first 3, we get this 1, 3, which then gives us 1, 3, 3 or 1, 3, 5. Now the next 3 here gives us this 1, 3, but it gives a duplicate combination of 1, 3, 5. Now that is specifically what we need to avoid. So as we are going in a for loop, we need to check if the current element that we are at is equal or the same as the previous element. If it is, then we need to ignore this particular path. Similarly, we have to ignore this path so we don't create duplicates. Same happens here. We are at 2. We explore all the paths for 2. Then we explore all the paths for 3, which is 3, 3, and 5. So we get 3, 3, 5. We get and 3, 5. Now, when we get to this 3 here, we explore all the paths and we see that we are getting a duplicate 3, 5. So we have to avoid this particular duplicate. So we have to avoid this 3. So in a particular for loop, as we are iterating over each element, which is this here, this code, we need to make sure that we avoid any number that has already occurred before in the same for loop. So what can we write as our condition here? We can say if the index, the current I that we are currently at is greater than the index, so that we are not taking just the first element, but we are going more than the first element. And the array of I, thus the current value is equal to the previous value, then we just return back. We don't explore that particular path. If not, then we continue our exploration, we create the path, and we recursively call the code. Now in this, there are certain other conditions that we can check and we can exit our exploration. The first is whenever our sum becomes equal to the target, we can add that to the result array and we can exit from there. So let's say our target given is 6. So when we are at this position 1, 2, and 3, the next explorations could be 1, 2, 3, 3 or 1, 2, 3, 5. Now we have to avoid this since we already got the target. The sum of this equals to 6. So we can check if the sum of the path is equal to the target, then we add that particular path to the result and we just return and we don't go into a recursive call, which is here. Another piece of code that we need to check is if the sum of the path is greater than the target, then we need to exit. So here the sum is 8, which is greater than 6. So we don't have to explore any of the path further here. Right now here we don't have any path, but we don't have to explore as well. So that's the second condition that we do, where without adding the result, this path to the result, we just return back from there. Taking these two conditions and this one condition here, we will be able to get all the paths that correctly add up to our target. And remember, whatever is the question given, we first need to sort it. Now let's say this is our given question 1, 2, 3, 3, and 5. After we have sorted the array, we get this particular array and our target is 6. Now imagine what happens to this code in the recursive stack. So first we call the recursive function with the value 0, which is our starting index, and we have an empty path. Our target is 6 and we also initialize a results array, which is an empty array. Now the sum of the path, but the path is empty right now, so it's not going to equal to target, and sum of path is also not greater than target. So now we start our for loop, which starts from 0 till n, and n here is 4. Now the first path that we create here would be path plus array of I, and array of I, which is here, this one, becomes 1. Now, we then call a recursive the same function again in a recursive manner, and we increment the I to I plus 1. So I was 0, now, sorry, index was, so this index value now becomes 1. From 0, it becomes 1. Now, when it comes back to this for loop, it runs from 1 till 4, right? So this one now runs from 1 till 4, and my path already is 1 here. So I add the array of I, which is 2, to my path. So now in my recursive call, my path becomes 1, comma 2. Now similarly, I again call the recursive and function, and this now the index value becomes 3, or sorry, becomes 2. And array of 2, which is 0, 1, and 2, array of 2 is 3. So now 3 is added to my path in my recursive call. So 1, 2, and 3. Now once this happens, you can see that the sum of the path is equal to the target. So we add this to our result. So this is added to the result array. And what also happens is you return back from that particular stack. So we return. So this called this stack, this called this stack, and you come back to your original one, right? So now we are currently at this position, and this one is now done. This stack is now done. Next, we continue our for loop, and we then get 1, 2, and instead of 3, we come to this 3 here. When we come here, we see that I is greater than index, yes, and array of I is equal to array of I minus 1, yes. So this 3 is equal to 3. So we return back from here as well. So instead of even considering this path, we come back to our original stack. Now we have 1, 2, and as we are going in the for loop, we have done with 3 and 3, so we do 5. And we see that the sum of this path is greater than the target, so we return back again. So we come back to our caller. Now 1 and 2 has been exhausted with this list. So now we become 1 and 3. So this called this internally called all of these stacks. Now from here we go to 1, 3. Now 1, 3 is fine, so we go into a recursive call, and then we go 1, 3, and then the next 3. But this 3 is exceeding our target, so 3 plus 3 6, 6 plus 1 7. So we return back to our caller. Let me just erase all of these. And we'll just cancel out those that are already done. So we're done with this, we're done with this tag, we're done with this tag, we're done with this tag. Now 1, 3, 3 is greater, so we're done with this, and our call goes back into the one that called it, 1, 3. Now 1, 3, next one is 5, but even this 5, the sum is becoming greater than the target. 5 plus 3, 8 plus 1, 9. So we go back to the caller, which is this, and we have 1 and 3. So we are done with 1, 3. So we then go to our next one. Now we can see that we come to this 3 here, and since we have these two values as equal, we skip over it, and this condition helps us in skipping that particular one, and we go to the next element, which is 5. So we do 1, 5, and we see that this is equal to the target. Sum of 1 and 5 is equal to the target, so we add this to our result here, and we return back our call. So When you return the call, it goes back to the caller, the first one, which is this. Now, since we have exhausted all the ones here, we then go in our for loop to the next number, which is 2. And same way, we start from 2 and we get 2, comma 3. Then we get 2, comma 3, comma 3. And this gets cancelled because the sum is more. So it comes back to its caller. This caller will then do 2, comma 3, comma 5, which again is greater than the target. So this goes back to the caller, and since it's exhausted all the paths, it comes back to 2, and 2 will go to the next element, which is 3, but since it's a duplicate, we skip over it and we go to 5. So my next element is going to be 2, comma 5, and so on. So this is how the recursive function works, and the stacks are created, and you explore all the paths. And we have our conditions wherever the sum of the path is equal to the target, we just exit from there. Wherever sum is also greater than target, we return back and we continue our exploration. So here's a solution for the problem. It's a bit enhanced, but follows the same concept. First, we sort our given candidates, and then we recursively call our backtrack or the recursive functions that we had written. We send the candidates, which is all the array of all the elements that we have. We have the target that we have to find the sum as equal to. We have the index position. We have the all the different paths that we are exploring, and we have an array which tracks all the answers that we find. And the same happens here. The only change here that we are doing, that I changed in the code, is that instead of doing sum of the path, as I'm calling the backtrack, I'm figuring out what is the sum coming to. So I can just do target minus the current candidate that I'm adding to my path. And if the target becomes 0, that means all the candidates that I have added to the path recursively are coming to 0. So I can add that to my answer. And that's how it works. You can see, try this code out. You can try the code by writing yourself, understand the concept, and see how you get the answer. So that is all for this particular question. You can try to solve this code by yourself. If you find any difficulty, make sure to go through the video again. Smash that like button and comment down below if you've leveled up your coding and problem solving skills today. Subscribe to the channel and we'll geek out together.